Hello, my name is Miguel, and I'm going to present to you my development project of the Universidad Autónoma of Ciudad Juárez, which is the programming and implementation of an algorithm for detection and counting of brake pads on a production line using computer vision system based on a WBA model. My testing supervisor is Hector Tobanche, so let's keep going. To begin, let's mention about the introduction. It's important to say that the automotive industry is always looking for new ways to improve production, quality, and efficiency. The advanced technologies like computer vision and artificial intelligence help to optimize component detection and classification. Mechatronics combines mechanical, electronic, and control engineer, boosting efficiency and innovation in the manufacturing area. It includes factory robots and automated guided vehicles. Computer vision systems ensure the metal surface quality through detailed inspection. AI uses advanced algorithms for real-time data classification and collision between humans and robots, improving the safety and efficiency on the area. These technologies can help to classify automated components. The combination of computer vision, AI, and mechatronics drives to innovation in the automotive industry, leading to the companies to use AI-based vision systems to inspect company quality, ensuring safety and compliance with all of the standards. Okay, so in this project, we made a research about some authors that made some investigations about the same topic as I did. So, one of these authors is Matsusaka. So today we're going to explore the key research in computer vision and AI in the industry based on those investigations. Matsusaka showed how the computer vision allowed to the machines to make human-like decisions by processing visual data enhanced further by AI. But on the other hand, Sang uses CNNs for accurate crowd counting, improving event management and surveillance. In another investigation, I found out about Sue's team, which created a TPH B5, which is an advanced model for detecting objects in drone footage, enhancing accuracy in the complex scenes, and also an investigation made by Brevity and Sigvera McCreech, who applied B5 to identify webheads from cell phone images, boosting efficiency in crop management. These studies highlight significant the advances in applying computer vision and AI across all the industries. Let's discuss a few things about the problem statement. The automotive industry needs precise and reliable systems to monitor the production of metal parts. It's very important to know how many parts are made in real time to make good decisions. For example, brake pads. Those are essential parts in car braking systems, and they have a complex shapes like fixtures, holes, and wear that may affect to some detection methods. The current methods like the using infrared sensors, lasers, and inductive sensors don't work very well for counting these brake pads accurately because they have a lot of complexity in the forms of the brake pads. So these systems are not very reliable, leading to errors in counting and also the reported counting in the system of the company. This can also cause delay in production and delivery to the customers. Additionally, these systems are very expensive, not very customizable, and also require support from the supplier, causing more delays. In the final assembly stage of the process, we can often see a lot of differences between the recorded number of the parts and the actual physical count of them. And this happened because a lot of parts get lost in early processes, such as defective parts, parts needing rework, or also poorly made parts. And without an accurate counting process during the production system, there is a misbalance in parts for assembly. These missing parts can delay the order completion, causing downtime. And also, too many scrap parts lead to extra inventory, adding storage cost and also a lot of waste. With this being said, we can establish the main purpose of this project, which will be to develop a brake pad detection and counting system in a production line using artificial vision based on a Jolo B8 artificial intelligence model. For the specific objectives, we can establish to analyze 10 existing techniques for counting and recognizing objects based on the Jolo B8 model to determine which of these techniques is the best one to use. Also, we can generate a dataset to be integrated to the training of a Jolo B8 model. With this, we can create a set of photos of the brake pad so we can train this model with those photos. And then we can program an algorithm for tracking and counting brake pads on the conveyor belt. This will be with the logic of object tracking and object counting. And finally, we can validate all of the results of the brake pad counting and identification system based on the Jolo BA model to determine if the techniques that we use are the proper ones for this kind of situations. Obviously, this objective needs to be accomplished to accomplish the first main purpose of this project. Let's talk about the justification of this project. This research advances mechatronic engineer by improving production monitoring in the automotive industry. Frequent errors in the counting brake pad show the need of better solutions. This AI vision system can accurately track and identify the brake pads, preventing a lot of mix-ups and shortage. This can ensure high product quality, better inventory management, and also a higher efficiency on the production planning. We can reduce all the costs and all the waste by saving those resources and also saving those costs, enhancing delivery times, and we can also boost the manufacturer's reputation with quick delivery time to the client. Automating this kind of process can also increase the competitiveness and also support the Industry 4.0 development. With all of this being said, the main scope of the project is developing an AI-based vision system so we can detect brake pads for the production line to precisely track those counts and models of each brake pad produced, addressing all of the shortcomings of traditional counting methods and also enhance the manufacturing process management in the automotive industry. Since we cannot have a perfect project and not an ideal project, we need to establish some delimitations so we can set what is going to be the things that our system will not able to do or what we have to work with. So the first thing is the video quality. This will be on the based on the frame rate that the POE camera can give us, the power of Ethernet camera. So we need to establish a frame rate based on those specifications of the elected camera. Also, the system performance will depend on the hardware that we select to process this training and also process the real-time detection. Also, the detection capability will restrict it to 640 pixels times 480 pixels because a lot of artificial intelligence are a little lower of this kind of specification, so we need to put a video input and have a better camera speed, better frame rate. And finally, the training data will depend on the diversity of all of the photos that we elect for the dataset. And finally, for the open point list, the remaining activities that we need to work on, the most important ones, will be the selection of the camera model so we can determine and establish the frame rate and the pixels of the image. Also, we need to create and customize an AI model based on the dataset tool, which is RoboFlow, a good tool that we can elect to use. We also will need to train a Jolo BA model with the tool of Ultralytics, some commands that they use. Also integrate that model with Python Anaconda for proper logic on the algorithm and use the necessary libraries, for example OpenCV. And finally, integrate those tools with the interface for the user will be with Oracle and Visual Studio with the use of the APIs. That's it. Thank you so much for your attention. This is all of the subjects that we address in the chapter 1 of this project. We're going to work on the next activities of the chapter 2, and also we're going to work on each activity on the corresponding time and corresponding date. Thank you so much.